So last lecture what we did was we started with the module number 5 of the course network theory, which is what two-port network. So essentially it is the two-port parameters which we study. So what are those parameters? First we saw Z parameters, then Y parameters. We saw in the sense we just defined them. Then we had ABCD parameters, A prime, B prime, C prime, D prime parameters, then hybrid parameters and inverse hybrid parameters. So Z parameters are called as what? Open circuit impedance parameters. Y parameters, the name is short circuit admittance parameters. ABCD parameters, technical name is transmission, and these are what? Inverse transmission. These are hybrid and these are inverse hybrid parameters, right? So then how was the equation defined for this? It was V1 comma V2 is a function of I1 comma I2. So since this is admittance, it should obviously be inverse. So I1 comma I2 is a function of V1 comma V2. And these are what? ABCD, and they are called as what? Transmission. So they talk about transmission. So from port 1 to port 2, something is transmitted. So V1 comma I1 is a function of V2 comma minus I2. Then inverse transmission from port 2 to port 1. So V2 comma I2 is a function of V1 comma minus I1. Then hybrid parameters, as the name suggests, means both sides you left ports 1 and 2. So I1 comma I2, sorry, V2. And both sides you will have voltage and current as well, which was not the case in previous parameters. So then inverse hybrid will be I1 comma V2 is a function of V1 comma I2, right? So this is what we saw last time, and we solved numericals based on Z parameters, right? So in the same way, same networks you can get, and they might ask you admittance parameters. Okay, so this I am not taking that, you can do it yourself, it is on the same grounds. So today we'll do ABCD parameters. So again, this you can do yourself. Okay, so I'll keep these questions in tutorial. Similarly, inverse hybrid you can do. So I'll keep 3 questions in the next tutorial. Okay, so let's go about this. So if you remember, in Z parameters we saw the condition of reciprocity and symmetricity, right? So the same thing we will see here. Okay, so first let's write the equation. So for transmission parameters, what is it? V1 comma I1 is a function of V2 comma minus I2. So what will be V1? It will be A V2 minus B I2. What will be I1? C V2 minus D I2. Right? So then obviously you can write this in matrix form, right? So again, how will A be defined? So we had seen cases for Z parameters. So what will be the similar cases here? Case 1, when output port is open circuited, what will happen? I2 will be 0, right? So when I2 is 0, I'll get V1 is A V2, right? So what will be A? V1 by V2, right? So A will be V1 by V2. And when is this possible? Only when I2 equal to 0, right? So if you have studied EDC, it is what? V2 by V1 it was. AV is V2 by V1. So that was called as voltage gain. But it is inverse of that. So that's why it is called as reverse voltage gain. Okay. So similarly, you can find C. It will be what? I1 by V2 when I2 is 0. So what is I by V? It is admittance, right? So and it is talking of from port 1 to port 2 or port 2 to port 1. So that's why it is called as transfer admittance. Okay. So then case 2. So when output port is short circuited, what will be 0? V2 will be 0. So if V2 is 0, what will be V1 minus B I2? So B will be what? Minus V1 by I2. So B equal to minus V1 by I2 when V2 is 0, right? So again it is V1 by V2, port 2 to port 1 and impedance. So this is what transfer impedance, right? Similarly you can find D, it will be what? Minus I1 by I2. So this was my V1 by V2, this is what I1 by I2, and this is valid when V2 is 0. So this is called as what? Reverse current gain, right? So next is what? Condition for reciprocity. So I'll write here only. So reciprocity, what will be the condition? It is AD minus BC equal to 1. So again derivation I am not taking, you can refer the book for the derivation. So again what I said, reciprocity means you can interchange the port 1 and 2, then also the output will be same. And then condition for symmetry, what is it? It was Z11 equal to Z22 for Z parameters. Similarly you will have here A equal to D. Okay, so based on this we can solve the numericals. So the first one is find transmission parameters for the network shown. So 1 ohms, 5 ohms, 2 ohms, this is I2, this is I1, right? So again what we do it for, if Z parameters were asked, what will we do? We assume the currents, right? So they are already given here, so you can say this is I1, this is I2. Remember I2 is anti-clockwise, right? So then we apply KVL to mesh 1 and apply KVL to mesh 2, right? So applying KVL to mesh 1, what will you get? V1 minus I1 minus 5I1. So V1 minus, okay, I'll write it stepwise. So V1 minus I1 minus 5 times what it will be? I1 plus I2, both are in same direction, equal to 0. So this will be V1 equal to 6I1 minus 5 minus 1 minus 6, and this is minus 5I2. So यहाँ पे आके plus 5I2. See in the exam what you have to write? Applying KVL to mesh 1. This is very important. Then how you are getting the equation you have to write, then you can directly write the equation, right? So here if you want you can use the shortcut method. 5 plus 1 is 6, then sharing is minus 5, right? And then equal to V1. In that way also you can write, but this and this line is important. Okay, so this is equation 1, then applying KVL to mesh 2. So what it will be? So I am going from like this. So V2 minus 2I2, again minus 5 times out, it will be I2 plus I1 equal to 0. So therefore V2 equal to 5I1 plus 7I2. So this is equation number 2, right? Now what is the question? You need to think. Again, don't buy at sums. So you have to find transmission parameters. So transmission parameters are what? ABCD parameters. So how are they defined? V1 comma I1 is a function of V2 comma minus I2, right? So write this in front of you. So V1 is AV2 minus Vi2. So I1 is CV2 minus Di2, right? So just check whether from the KVL we have got the same equations. So what you want V1 as in terms of V2 and I2. A and B will be some numbers. So V1 is in terms of I1 and I2, but right? Means what? What is not required? I1 is required? No. I2 is required? Yes. Means what you have to do? Eliminate I1, right? Right. So what you can do to find this I1 from equation 2, you find I1, right? So this is the way you should solve the sums. Okay. So we can write from equation 2, what will be I1? So 5I1 will be V2 minus 7I2. So I1 will be 1 by 5 V2 minus 7 by 5 I2, right? So what we can do, put 3 in 1. This is equation number 3, sorry, right? So 3 in 1, sorry, this one. So I'll take a new page now. So what we'll get? So V1 is 6 times 1 by 5 V2 minus 7 by 5 I2 plus 5I2. So just solve this and let's see what we get. So V1 is 6 by 5 V2, that is alone. So 6 by 5 V2, then 7 6 are 42 minus 42 by 5 plus 5 I2. This plus 5 and this is minus 42 by 5. So 5 minus 42 upon 5. I made a mistake. So how much is it? Minus 17 by 5. So minus 17 by 5 I2. Right? Let's say this is equation 4. So what we wanted? We wanted V1 in terms of V2 comma minus I2. So what is V1 in terms of V2 comma minus I2, right? So this will be our this equation, right? So next we want I1 in terms of V2 and minus I2. So let's see, we had found I1, right? So it is already I1 in terms of V2 and minus I2, right? So we have automatically got both the equations. So equation 3 we want and equation 4. So next what we will write? From equations 3 and 4. Okay, we can directly write the parameters. A, B, C, D. Obviously, you always have to write them in matrix form. So this is V1. So 6 by 5 minus 17 by 5. Then what is I1? 1 by 5 minus 7 by 5. So 1 by 5 minus 7 by 5. Sorry, this will not be minus. This will be plus. Because minus sign is incorporated in the definition only, right? So that's why we will not write minus. So be wary of that. Okay. And make sure this is V1, right? So this will be in the first row. If you interchange these two rows, then your answer is wrong. Okay. So make sure you don't do those silly mistakes. And be wary of this minus sign, whether it will not be there. Let's do the next sum. So again, obtain ABCD parameters for the network shown. So again, same type of sum, only thing is one loop is extra. So as usual, this is V2, V1, this is I1, this is I2, 1 ohms, 1 ohms, 2 ohms and 2 ohms. Right? So what we'll do again, we'll assume mesh currents. So as I said in the last lecture also, first clockwise, this will be clockwise, and the outermost loop always take it as anti-clockwise. Then it becomes simple. Then what we'll do again, applying KVL to mesh 1. So what will you get? V1 minus I1 minus 2 times, what it will be now, I1 plus I2 or I1 minus I2? This is going downwards, this is going upwards, right? So I1 minus I2 equal to 0. So therefore V1 equal to 3I1 minus 2I2, 2I3. I'll take this as I3 and this as, yeah, this is I2 only, because we are taking this as port 2 and port 1, right? So that is why we keep this current as I1, this current as I2. That is the reason we keep it that way. And then it will tally with our parameters, two port parameters, that is Z, ABCD, etc. parameters definition also. That is the reason. So this is equation 1. So next, applying KVL to mesh 2. So what will you get? So mesh 2 is this. So V2 minus 2 times what it will be? I2 plus I3, both are downwards. So I2 plus I3 equal to 0. So therefore V2 equal to 2I2 plus 2I3. So this is equation 2. Then only one loop is remaining, or mesh. So applying KVL to mesh 3. So let's say I start from here. So minus 2 times, this is upwards, this is downwards. So I3 minus I1 minus I3 minus, both are downwards. So 2 times I2 plus I3 equal to 0. So therefore this will be what? 2I1 minus 2I3 minus I3 minus 2I2 minus 2I3 equal to 0. So therefore, and before this, what you can do is you can think what you want. Again, V1 comma, what was it? I1 is a function of V2 comma minus I2. So V1 should be in terms of V2 comma minus I2. But what you are getting? I1 and I3, right? Means you don't want I3 and you don't want I1 as well, right? So what we will do? So we can directly write I3 from here, right? So therefore what we'll get? This will be minus 2 minus 1 minus 2. So minus 5 I3. So I'll take it to the right side. So it will be 5 I3 equal to 2 I1 minus 2 I2. So therefore I3 equal to 2 by 5 I1 minus 2 by 5 I2. This is equation 3, right? So as I said, this is not required. So let's substitute 3 in 1 and let's see what we get. Okay. So put 3 in 1. So therefore V1 equal to 3I1 minus 2 times 2 by 5 I1 minus 2 by 5 I2. So therefore V1 equal to 3 minus 4 by 5. 3 minus 4 by 5. It is not clear. Yeah. So what is it? 11 by 5. So 11 by 5 I1. This will be plus 4 by 5. So plus 4 by 5 I2. Right? Let's say this is equation 1. So V1 is a function of I1 comma I2 we are getting, right? So still we require something, right? So now next what we can do? Again we want I1 as V2 comma minus I2, right? So this equation is also not helping, right? So next what we can do? Let's see equation 3. That is I3 is 2 by 5 I1 minus 2 by 5 I2. So what we can do? If we substitute this here, we will get V2 as a function of, again, what? I1 and I2, right? So V2 as a function of I1 and I2, right? So V2 in terms of I1 and I2 you will get. So what you can do, you can take this I1 here, you can take this V2 here. So I1 will be a function of V2 comma minus I2, right? So this is the way you have to think. So next, put 3 in 2. So therefore V2 equal to 2I2 plus, I'll directly write this, 4 by 5 I1 minus 4 by 5 I2. So therefore V2 equal to 4 by 5 I1 as it is, and 2 minus 4 by 5. 2 minus 4 by 5, it is 6 by 5. So, and plus, so plus 6 by 5 I2. So find I1 from this. So therefore 4 by 5 I1 equal to V2 minus 6 by 5 I2. So we want I1 only, right? So I'll write here. So therefore I1 equal to 5 by 4 V1 minus, what it will be, 6 by 4, so 3 by 2. So 3 by 2 I2. This is equation 5, right? So we have got I1, right? So this I1 we want in first equation as well, right? So V1 is a function of I1 comma minus I2. We have already substituted that. So we have got I1 and I2 here, right? So what we can do? So we can, this is equation 5. So if we substitute I1 here, right? So it will be what in terms of V1 and I2, right? Why we are doing this? क्योंकि ये plus sign नहीं चलेगा, minus ही चाहिए as per definition, right? So let's try and substitute 5 in 4. Well, right here. So put equation 5 in equation 4. So therefore V1 equal to 11 by 5 times 5 by 4 V1 minus 3 by 2 I2. Am I correct? Yeah, plus 4 by 5 I2. That was remaining. So therefore V1 equal to, this will be 11 by 4. I1 is in terms of V2, right? This is V2. 11 by 4 V2 minus 33 by 10 I2. So minus 33 by 10 and plus 4 by 5, plus 4 by 5. So minus 5 by 2. So minus 5 by 2 I2. This is equation 6. Right? So just see equation 5 and 6. What we want? V1 comma I1 is a function of V2 comma minus I2. Right? So V1 is a function of V2 comma minus I2. Here I1 is a function of V2 comma minus I2. So what you will write? From equations 5 and 6 we get A, B, C, D. So 11 by 4, 5 by 2. Again minus sign is not considered. 11 by 4, 5 by 2. Then 5 by 4, 3 by 2. Right? So this is our final answer. Right? So this is the way we have to solve. So let's take one more sum for the day and then we can stop. So if you observe, we had only resistors in these two sums, right? So there were no inductors or capacitors. So let's take one sum of that type so that everything is covered. So again same question. Determine transmission parameters. V2 plus minus I2. This is 1 ohms. This is S. So they have already given in transformed way. So V1 plus minus. What we'll do if this was as 1 Henry and this was 1 farad? Then we will have to convert it to transform domain, that is Laplace domain. तो क्या हो जाएगा L into S. So if L is 1 Henry, S, then 1 by CS. So since C would be 1, so 1 by S. Right? So then what you can do? So I am taking this particular sum is, you saw this here. In the first sum, it was not tricky. We got equation 1, equation 2, right? We just took equation 2, found I1 and then substituted here. We got V1 in terms of V2 comma minus I2, and automatically I1 also we got V1 in terms of minus I2. But when one loop was increased here, as shown here, one loop was increased, how many times we have to do substitutions? You apply KVL 2 times, 3 times, sorry. Then what you do? Where is that page? Yeah, here. Then what to do? You put 5 in 4, then put 3 in 1, then again 3 in 2. So then you have to do it 3 substitutions, right? So that is the reason this KVL method is not usually preferable, but it is very simple. Okay, but if you want to reduce the number of equations, what you can do is instead of applying mesh currents, you can use nodal analysis. So this will be node 1, let's say, and this will be node 2, right? So what we'll do? Again, if you want, you can solve this using KCL, not an issue. In fact, I will prefer if you want, you can solve this using KVL, take mesh currents and solve. I prefer KVL only. Okay, but just for the sake of completion, I am taking this. If you are comfortable with KCL, so applying KCL at node 1, right? So what you will get? This is, let's say, incoming. So incoming should be outgoing. So I1 is V1 by S plus V1 minus V2 upon 1. So V1 minus V2 upon 1. So therefore I1 equal to, so collect the terms in V1, so 1 by S plus 1. So if you calculate, it will be S plus 1 upon S times V1 minus V2. So this is equation 1. Again transmission parameters, so V1 comma I1 is a function of V2 comma minus I2, right? So I1 should be V2 minus I2. So I1 is V2. So we later on will substitute this V1. So then applying KCL at node 2. So what will we get? So I2, let's consider this as incoming. So I2 is V2 upon 1 by S plus V2 minus V1 upon 1. So this will be what? SV2 plus V2. So S plus 1 times V2 minus V1. So this is what I2. So if you see, I have V1 here. What it will be if you take it here? So therefore V1 equal to S plus 1 times V2 minus I2. So directly got V1 in terms of V2 comma minus I2, right? So this is, let's say, equation 2, right? So next what we need to do? We want now I1 in terms of V2 comma minus I2, right? So ये V1 गड़बड़ कर रहा है, right? So just substitute it from equation 2. So put equation 2 in 1. Okay, so what will happen? What was I doing? Equation 2 in 1. Yeah, so this equation 2 in 1, right? So therefore I1 equal to S plus 1 upon S into S plus 1 V2 minus I2 minus V2, right? So therefore I1 equal to S plus 1 the whole square upon S V2 minus S plus 1 upon S I2. I forgot this, so minus 1. Right? So therefore I1 will be, so just solve this. So s square plus 2s plus 1 minus s. So s square plus s plus 1 upon s into v2 minus s plus 1 upon s I2. So I1 is a function of v2 comma minus I2. Right? So what we will say? So you have got v1 in terms of v2 comma minus I2, v1 in terms of v2 comma minus I2. Right? And I1 should be in terms of v2 comma minus I2. So that's you have got here. So what will be your answer? A will be, so what will be A? So A, B, C, D. So A will be s plus 1 v2 comma minus I2. So 1, then s square plus s plus 1 upon s. S square plus s plus 1 upon s, and this will be s plus 1 upon s. Right? So this is your final answer. Right? So similarly you can solve for inverse transmission. Right? उसमें क्या अलग रहेगा? Now we had what? v1 comma I1 is a function of v2 comma minus I2. Right? So in that case, for inverse transmission sums, it will just be interchange. So v2 comma I2 is a function of v1 comma minus I1. Right? So that you can do. Okay.